We now start a series of videos on enzymatic catalysis. The first thing that we're going to do is define what a catalyst is. And the definition of a catalyst is pretty simple. A catalyst is a substance that does not participate in the overall reaction, but makes the reaction faster. Okay, to illustrate what a catalyst is, just think of a reaction A to give products. This reaction will have a rate, which might be fast or slow. And the idea is that this reaction, if this reaction is catalyzed by a catalyst C, okay, A plus C, to give products plus C, notice that C is actually not part of the overall reaction. Okay, is neither consumed nor generated in the overall reaction, but it makes the reaction faster. So that's kind of the idea. Now, the reason that it makes the reaction faster is because it provides an alternative mechanism for the reaction. Okay, so when A turns into products, the way that A turns into products is going to be different in the uncatalyzed reaction than in the catalyzed reaction. So what you should expect to find is that initially you're going to have an elementary step in which A combines to the catalyst, and that generates some sort of products of that AC. And then in a later stage, what happens is that reaction takes place, and ultimately the catalyst needs to be regenerated. Right? So again, when you add all of this up, okay, that is the enzyme catalyzed reaction, these three steps, you get that the net is the reaction that you're looking for, but now the reaction is faster from this alternative mechanism provided by the catalyst. All right, so catalysis is very important in many fields. It's a multi-billion-dollar industry. It's part of a huge chunk of the GDP of the United States, and it participates in many other reactions. Virtually every single reaction inside our bodies is catalyzed by some sort of catalyst. In generic terms, there's three types of catalyst or catalysis. One of them would be homogeneous, then you have heterogeneous, and then you would have enzymatic catalysis. Homogeneous catalysis is that in which the reagents and the catalyst are in the same state of matter. Right? So when you've gone to the lab, in the organic lab, when you have a base catalyzed reaction or an acid catalyzed reaction, usually you have solutions of both the substrate and the catalyst, and that would be an example of homogeneous catalysis. Heterogeneous catalysis is that in which the catalyst and the substrate would be in different states of matter. So for example, the catalytic converter in your car, what those catalysts do is they convert gases that are toxic, usually nitrogen oxides and sulfur oxides, into more benign gases, right? So it catalyzes the reaction of a gas, but the catalyst is in a ceramic mesh, right? It's in the solid state. So that would be an archetypal example of heterogeneous catalysis. Now, enzymatic catalysis would be a type of homogeneous catalysis because usually both your enzymes and the substrate will be in the solution phase and the aqueous phase, but it's a sufficiently different type of, or sufficiently removed type of catalysis that it constitutes a class of its own. Right, so enzymatic catalysis has very many hallmarks, if you want to. Okay, so if this is your, that's going to be an enzyme, so the way that we're actually going to usually write these reactions is you're going to have a substrate with an enzyme to give a product with the enzyme. Okay, the type of rate enhancements that you get from these reactions can be very large. Okay, so some reactions can be accelerated from the order of 1,000,000 times faster to 10 to the 18 times faster. What this means is that virtually there are reactions in biological media that would not take place at any appreciable rate. What the catalyst does is it makes a reaction possible at a sufficiently fast rate. Okay, so again, it's the difference between the reaction not taking place and the reaction actually proceeding. Okay, we also know that enzymes are very specific. Okay, so some of them are chiral, and that means that they will catalyze the reaction with one of the stereoisomers or the enantiomers of one molecule, but not with the other one. Okay, and we also know quite a bit about the structure of enzymes. Until recently we thought that most enzymes were proteins, and they were just constituted of a bunch of amino acids in which only a few of the amino acids that reside in the active site were responsible for catalysis. Okay, but more recently we actually learned that there are some nucleic acids, ribozymes, that can also catalyze reaction. And of course, that was the Nobel Prize in 1989. Okay, so that's kind of an introduction to catalysis, just touching on what is a catalyst and the types of catalysis that you have, and also focusing now on enzymatic catalysis, which is going to be the only type of catalysis that we're going to study extensively in the next few videos.